Okay. Hello everyone, welcome back. Nice fireplace stream today. So yeah, again we're doing Advent of Code. Of course, Advent of Code day 6 today. I saw someone the other day who commented on the live stream on YouTube. Like I just went into the YouTube stream to check something because this is streamed at the same time to both Twitch and YouTube. And apparently someone had been leaving comments in the YouTube chat, and those apparently don't propagate over to Twitch, so I hadn't seen them. So sorry about that. I'll try to keep up with the comments in both tabs here today. Yeah, that was that. So yeah, today, day 6. Yesterday we had the volcanoes, or the underwater geysers, I guess. So let's see what we have in store for us today. The seafloor is getting steeper. Maybe the slay keys got carried this way. That's probably a good idea. Stuff tends to fall down underwater. A massive school of glowing lanternfish swims past. These are... Oh, okay. That's not the ones I thought they were. Okay, I thought they were the ones with like a lantern on their head. Thanks. Where was that comment? Was that just on Twitch? No. On... Oh, right. It's just in the AoC channel. Someone said I had a nice beard, in case you couldn't see the notification. They must spawn quickly to reach... they must spawn quickly to reach such large numbers. Maybe exponentially quickly. I guess anything. Like, as long as you don't have stuff dying off, I guess anything, any organism with more than two children per sort of generation would grow exponentially. You should model their growth rate to be sure. Although you know nothing about this specific species of lanternfish, you make some guesses about their attributes. Surely each lanternfish creates a new lanternfish once every 7 days. Surely. I mean, obviously. However, this process isn't necessarily synchronized between every lanternfish. One lanternfish might have 2 days left until it creates another lanternfish, while another might have 4. So you can model each fish as a single number that represents the number of days until it creates a new lanternfish. That makes sense, I guess. Furthermore, you reason a new lanternfish would surely need slightly longer before it's capable of producing more lanternfish. That makes sense. Growing to maturity before you can make more. 2 more days for its first cycle. So 7 days for a normal cycle, and then 2 more days for the first one. Let me just... hold on a sec. There. I realized my pop filter was touching the microphone. I wasn't sure if that would create some nasty pops in the audio. Right. I've heard people talking about, like, you should monitor your audio, like wear headphones while you're streaming, so you can hear yourself. I'm not gonna do that. I don't want to sit here listening to myself on a delay. That sounds like It sounds like it would be very not confusing, but very, I don't know. I don't like the idea of that. Right. So suppose you have lanternfish with an internal, oh, okay. I have a lanternfish with an internal timer value of 3. After 1 day, its internal timer would become 2. After another day, its internal timer would become 1. After another day, its internal timer would become 0. After another day, its internal timer would reset to 6, and it would create a new lanternfish with an internal timer of 8. So new ones have a timer of 8, old ones are just reset to 6. Because from 6 to 0 is 7 days. After another day, the first lanternfish would have an internal timer of 5, and the second lanternfish would have an internal timer of 7. Again, that makes sense. A lanternfish that creates a new fish resets its timer to 6, not 7, because 0 is included as a valid timer value. Yeah, so every 7 days, that would mean the days ranging from 0 to 6. That makes sense. The new lanternfish starts with an internal timer of 8 and does not start counting down until the next day. That also makes sense. Realizing what you're trying to do, the submarine automatically produces a list of the ages of several hundred nearby lanternfish. How handy. This submarine really has some oddly specific equipment on board. Yeah. So, for example, suppose you were given the following list: 3, 4, 3, 1, 2. This list means that the first fish has an internal timer of 3, the second fish has an internal timer of 4, and so on until the fifth fish, which has an internal timer of 2. Simulating these fish over several days would proceed as follows. So initial state, and then all of them tick down by 1, tick down by 1 more, and this one spawns another fish, and then this one spawns another one, and then this one, this one and this one spawns these two, so on and so forth. Each day a 0 becomes a 6, and adds a new 8 to the end of the list, while each other number decreases by 1 if it was present at the start of the day. In this example, after 18 days, there are a total of 26 fish. After 80 days, there would be a total of 5,934. Right. Find a way to simulate lanternfish. How many lanternfish would there be after 80 days? So we can get our puzzle input here, which is just the long list of single-digit numbers. Should be easy enough to parse. And then I'm gonna store this. I'm going to store this as input example.txt so that we can test our algorithm on the small input where we know the result. So we can test our algorithm before we get going. Oops. Import. We're going to be using string utils for the splitting. That should be everything we need, I think. So actually we can do this as a var. So let var fish is equal to read the entire input example.txt file and then split that on the comma character. So this should now give us a list of fish. That's good. But these are strings, and apparently they also have a new line in them. I'm not sure if The original one didn't seem to have a new line. Okay. So this also has a new line. Okay. So I guess we then can't do this. Oh, we need secutils for map. Yeah. This is a bit confusing. Invalid integer 5. Value error. So this looks like a valid integer because it doesn't have any quotations. I really think what Nim should do when outputting this is to include like the like new line character, like the line feed, like the visual line feed character, like this one, instead of just saying 5 and then, because this, if I was new to them, this would be hard to realize. We're just gonna do map it, and then we're gonna do its dot strip strip white space, I guess, dot parsent. Nope. Strip new line dot parsent. No. Wait, is strip oh, right. Okay, just strip would work. There we go. So yeah, map takes the name of a procedure and just applies that procedure to every entry in the list. So this reads the entire file in as a string. This part splits that string into a sequence of strings, and splits, of course, on the character that we pass. One thing to notice here is that Nim uses normal quotes, like the double quotes, for strings, and single quotes for a single character. When I did this, that is just, oops, this is just an escaped new line. This is still a single character. This used to be a confusing thing in Nim because we had backslash n was not the new line character. It was platform dependent. So on Windows that would be CRLF. On Linux that would be just ln. So you wouldn't be able to put that in strip because it could be a string. But yeah. Map bit. So yeah, this splits it into a sequence of strings. Map takes a sequence of something and a procedure that takes an element of something and returns something else. And that can be a different type. So when I first had map parseInt, that's just going to run the parseInt function on everything in the list that we give it and returns a new list that has the type of parseInt as the return type. Parse it as parse with an iterator variable. So here, this is actually a code statement. This is a block of code. Like we can put this on a separate line if we wanted to. This is a template that runs the same loop, but inserts this in a specific place in the code. So instead of taking a single procedure, this gives us a variable called it that we can then do stuff with. So this is a bit more flexible. Like we could have written let's entry equals it, and then we can do entry.strip as so we can like name this strip, for example. We can even like echo out stripped if we wanted to, and then we can return implicitly just because it's the last thing. Just because it's the last thing in the block, we can return that. This would do the same thing. As you can see here, it now echoes out all the numbers, and it returns a sequence of numbers. So this is a lot more flexible than just a single procedure, but it's good to know that they both exist. So there, if we now read in the example input instead of the actual one, it's a bit shorter. And now we can start our stepping. So we want to do this for 80 days, but we're gonna simulate just 5 days to begin with, just so we have, or 6 days. This would be 5 days. This is 6 days, because this one dot in nim is inclusive. So let's just do 5 days to begin with, just so that we can verify our input. And then we're gonna say for I in fish.mytems. So typically, actually it's a bit annoying that fish is the plural of fish. Let's call this a fish list. And then we can say for fish in fish list. So this, now we get each of the fish, right? Now we get the separate fish. Of course, this is printed 6 times. But I can't do anything with fish. Like I can't do this. I can't decrement these. But if I run, so this is the same as calling the items iterator. This is the exact same code. But what I can do is run the mytems iterator instead. That is the mutable items. That means that fish here is now the number in the list as a mutable variable. So I can now change this. And if we look at this, we have, so the first day, let's actually echo out a nice little line there so we can see the days. So this is our first day, our second day, and then our third day, because we don't yet handle these, fourth and fifth and sixth day. So that's fine. Why? Ah, there we go. So now we decrement all of those. If fish is equal to zero, fish is going to be equal to 6. So that brings the numbers are back around. So actually we should do that on the next day. So we should do this. So moving that before obviously means that if it's 0, it's not going to go to -1. It's going to go to 6. And then of course we don't want to decrement this right after we have set it to 6. We could of course set it to 7 and always decrement, but there. So now this goes to 0 and then it hops back up to 6. Same with this one, goes from 0 to 6, and these two go to 6. But now we need to spawn in fish. And one thing that you can't do in them, we can't do something like this and say So if the fish is 0, fish list dot add 8, we can't do this because this errors out actually on runtime that the length of the sequence changes while iterating over it. And this is sort of a feature of the language that, like, you shouldn't, if you don't know what you're doing, it's easy to mess up when you do this kind of thing. One way to get around it would be to do for I in 0 dot dot fish list dot length, and then say our fish is fish list I. So we can see now it doesn't index defect because we're going to length instead of to the highest index. So as you can see now, this works. It actually doesn't decrement. Right, because this is no longer sort of a cursor into the list. What we can do to emulate that is say that fish, I think just that works. Nope. Fish is an integer. It's a template, and templates are expanded on compile time. So this will be replaced by this on compile time, and then obviously this will now be this fish list inserted there. So it would mutate in the way that we expect it to. So now when we run this, we can actually see that we have a 0, like this 1 turns to a 0. And then on the next iteration, it's 6. And we have added this 8. And the same here, this 0 turns into a 6, and we add an 8. And the last 8 here, of course, goes to a 7. So this actually looks correct. And the reason why this doesn't mess up is because this fish list.high is sort of, it's locked in before we start looping. So it reads out the fish list.length once before we start looping. And then we can add stuff to it without this sort of getting updated. This is nice if this was an expensive function, for example. If this was a function that did something expensive, this is a nice little speed boost. Of course, it means that you can't change the condition of the loop while you're running. In that case, you have to use a while loop. So yeah, that should actually now be correct. If we look at our numbers here, so after 18 days, it should be a total of 26 fish. So if we say simulate 18 days, and then echo out fish list.length, this should give us 26. Yes. So there's 26 here. And if we run this for the full 80 days, so from 0 to 79, then we have 5,934, which is the number we expect here. So let me now remove these so we don't spam our console too much, and then run this on the actual input. There we go. This should now be the number of fish that we expect. Hurrah! Correct answer. So this this usage of template is not very common. I haven't seen a lot of people do this, but it is a way of creating sort of an ad hoc alias from one thing to another. So it definitely works. But yeah, you want to make sure that you don't put anything expensive in here, because this is going to be looked up every single time. But yeah, but it works. So yeah, that was kind of easy. Part 1. Let me now copy part 1 over to part 2. And then we can have a look at what part 2 is. Just as a note, like we could, a lot of these, or all of these so far, we've been able to solve with just the sort of the dumb brute force way. Just like say exactly what this means, like implement exactly what this says, and we're fine. As the days progress, we probably won't be able to do that, because they get harder and harder. And actually, one thing, so I looked at the comments for this, and a lot of people seem to like when I call out other solutions. So from now on, I think I'm gonna try and call out a cool solution every day, or maybe a couple. I have another solution that I want to show as well, but this one is not a cool solution, but this is day 5. He calls it part 3, and day 5 was the calculation of like intersecting lines. But the way it was worded, like it gave you like a full algorithm for it, and it did it had the whole like you can do this, like the input was small enough that you could just do an array. What I did, of course, was I used a count table, but with this input, first off, there's more lines. There's way more lines that we need to check. And the lines are in such a big space. So many of them are far apart, but the lines are also super long. I tried to run this on this machine, and I just ran out of memory, and it crashed. So like not even my solution that doesn't create this massive big array doesn't work on this input. It might work on like a subset of this. It should work fine on a subset of this, but it doesn't work for the whole set. And this guy, Michael Marsalek, I'm not sure where he's from, so I'm not sure how to pronounce that. He writes his solutions in Nim, so you should totally go check out his GitHub for some crazy solutions. Well, I actually look at one of them afterwards. But I tried to code my solutions to be able to handle more inputs, and in the like as we progress through these, we probably have to implement some smart algorithms. Of course, what you have to do with an input set that big is to calculate overlapping lines, and just store like the pixels where lines overlap. Instead of counting every pixel, you have to go through like a double loop, one that does all the lines, or one that goes through all the lines, and the inner loop that also goes through all the lines and checks for intersections. And then you store the intersections to make sure that you don't count an intersection more than once. And of course, you need to handle like 2 lines overlapping like this. So like multiple pixel overlap. So it's an interesting challenge for sure. Right, anyways. Suppose the lanternfish live forever and have unlimited food and space. So basically no restrictions to this spawn rate. Would they take over the entire ocean? After 256 days, in the example above, there would be a total of, I don't know, a couple billion fish, I guess. Million, billion, yeah. Or milliard, as we would say in Norway. Or in the long or short system. In English. So, yeah, 256 days. So this is actually just the same code, just with 256 days. So now I guess we will see if we're gonna run out of memory again, because these are gonna be a lot of fish, and this is gonna probably take a while. I'm actually gonna compile this in. So this is a nice thing. We can compile this in release mode. So normally, if you've looked at the output when I'm compiling, like if I compile this again, it says optimizations none, debug build, use dash release, or dash release generates faster code. So when we put dash release, we get faster running code. So now it says optimized for speed. You can also optimize for size. We have the dash D release flag, and we have the ref count garbage collector. You could also run with dash D danger. This removes a couple of assertions. So it's basically release mode with more assertions removed. So for example, you aren't allowed to change the size of a sequence while you're iterating over it. That assertion is gone when we're compiling in danger mode. So basically fewer checks. We can also, if we want to speed things, probably won't do the biggest difference on this input, because we're only dealing with integers. Well, we are creating a bigger and bigger sequence, so I guess it might be, is using the arc or orc garbage collectors. And of course, we also have all the C optimizations. We can do link time optimizations, for example. I'm not sure if any of this is actually necessary, or even I might have to do even more stuff to be able to run part 2 here. But yeah, so we really have a lot of options to optimize them for different things. Yeah, I seem to be running. This machine has 10 gigabytes of right. I'm not sure if that. Yeah, it seems like the stream started stammering there. I ran out of memory. So we're not able to do it this way. And that means that we need to do it another way. So this one is actually the first one where we have to do stuff a different way. Yeah, my computer is indeed crashing. I mean, my shell is smart enough to terminate stuff like that on its own. So yeah, what can we glean from this? So we know that after 1 day, we will increase by 1. After 2 days, we will increase by another 1. After 3 days, we will have even more. And after 4 days, we have gone through all of the initial, all of our initial ones. So sort of we can calculate, just based on this, we can easily calculate this thing. Which is interesting. We can of course also, so when we sort of have this 1 here, we know that after the first day it's 1 bigger. Then we also know that after 8 days, we will increase again, because the 1 that we spawned here is now going to be 6. All right, yeah, that spawns that one, and this is spawned by the 1 that spawns here. So this 8 here is going to count down, and it's going to create a new 1 down here. So we know that every 8 days after this is, or after 8 days after this is created, and then every 6 days we're going to have more. So we don't, what I'm trying to say here is that we don't actually need to store these and count them down every single time. What we actually just need to do is to create some kind of equation that is gonna calculate this for us. And now just to figure out how to do that. So as I said, going from this to this is pretty simple. But that won't take us far enough, because we will still, like, if we store these numbers, we're still gonna run out of memory. The problem here is that we can't store too many of these numbers. But we know I guess we can do this in let's see, I'm just trying to think here. So for any number, we should be able to figure out how many fish, like if we only have the number 1, how many fish will that give us after 256 days? I'm not sure, this code might be able to actually do that for us. If I, because the actual input list of fishes, well, first off, let's see if it can handle the example input, just because I'm curious. I'm gonna kill this off if it gets close to using all my memory. It looks like it might not be able to do it. Yeah, I'm gonna kill this before my stream starts lagging out again. Right. So it's not even able to handle this. I'm kind of... I don't think it's going to be able to handle this either, but I'm gonna try with just the 1 in there. So if we have 1 fish that's going to spawn a new fish in 1 day, can it figure out how many fish we need? I don't think it's going to be able to do this. Because this should grow really, really fast. Yeah, it's not able. Right. Let's actually keep at this. So we initially had 79. If you look at this, That's 1401. If we go one more iteration, well, not one more. Let's go to, I guess, 101 iterations. See what this gives us. Right. So there we went 20 iterations or 21 iterations more. And these are, of course, now adding to sort of the problem. If we do this, we can do something fun. If we do this, this I'm just doing for the fun of it. I want to make a nice little graph. Of course, we could. Oops, that was the character I used earlier. We want to do this. Yeah, that looks good. You want to create a little graph. Just create a line graph, and you can see the result in the background here. So yeah, this is what our results look like. They start out slow, and at first we went with like 80 iterations. Now we went to 100 iterations, and you can see the problem with going to 256 iterations. It just gets crazy big really fast. I have the delete key, so apparently I can't delete a chart. Let's just do that then. So if we can figure out sort of the algorithm for like how many a one is going to be, these you laughed hard at that include. Oh, are you talking about the include what was it, day 2 or something, where you just included the input? I really liked that one. That was good. These spam bots are really annoying. And I think my Twitch is broken because it says failed to load module whenever I click on them. I can ban them, but that doesn't really help. Well, I guess it kind of does. I'm not sure if banning them actually flags them for Twitch. Maybe it does. So yeah, anyways, if we can find sort of an algorithm for how many fish one fish will give us in 256 days, and how many fish a 2 will give us in 256 days, and so on and so forth, then we can have an algorithm that just gives us the input or the output. But my algebra skills aren't the greatest. So this would be for each 6 days, a 1 will generate another 1. And those have, no wait, for every 7 days, or for every 9. These fish generate another fish, and the new fishes only have 9 days. Or they have 9 days before they come into that 7-day loop. I mean, Regression with machine learning. Well, I mean, obviously I could try to like plot this into some program and then just, hey, spit out what this will be after 256 iterations. Best guess. But if that misses, like if that misses by 1, I'm still gonna get bad result. Like that's not gonna be an accepted answer. Right. So a 0 would take 7 days. A 1 every 7 days. So if let's do something here, just do this. Let's not add in new fish. Wait, what? Don't go on in this path. My brain is gonna fry. I don't really know which other path I'm supposed to go, to be honest. Probably is some neato little algorithm for this, but I don't know it. So yeah. Oops. That's just going to be 1. So a fish with the number 1 is going to spawn 15 fish in those 100 days. In 256 days, it's going to spawn, this should be quick enough to just do like this. It's going to spawn 37 fish. 0 fish is going to spawn 37, right? 2 fish. Yeah, sure, you can give a non-spoiling hint. Right, so all of these appear to give me 37. Okay, 4 gave me a 36. Then I'm guessing that the rest of these are also going to give me a 36. And then an 8 is going to give me 36. So I need to know when they are spawned. Or do I? Yeah, count the fishes. Wait, was that your hint? Count the fishes? 5 fishes. Ah. That was the count. What do you mean count the fishes? Right. So a 1 1 through 4 is going to spawn 37 fish in the 255 days. And an 8 started at the very beginning is going to do 36 fish. And a 5 and a 6 is also going to do 36 fish. Count the days. Yeah, 256 days. I think we're thinking kind of the same thing. Like, what would counting... I mean, if I count both of them. But it's not going to be just a simple... Right, okay, so you say, I mean, you don't have to store all of them, just 0 to 9 with some count. Oh. Right, I see what you mean. Right. Oh yeah, that's way easier. What am I doing? I'm doing this for like an idiot. Okay, so now I got what you were saying. I guess I did need that spoiling hint after all. So basically, instead of having a list of fish, we can have actually not a tables. Let's do an array. So let's do our fish list as an array from 0 to 8 of integers, so it's just a count. And then I guess we have do we have, well, doesn't really matter. We're going to do input example, but we are going to do for fish in this. So these are now again just the strings. I guess we can parse them out as a number. This is going to be really fast anyways. So fish list of fish plus equals 1. So in nim, everything is 0 initialized. So this array is going to be full of zeros. And it's going to be able to be indexed from 0 to 8. What you can do in nim is actually do stuff like this. 10 to 15, for example. And now you have to start your array indexes at 10, which is weird. But if you have specific input data, that is sort of the way to do it. And someone on Twitch says EQF. I'm not sure who you are. EQF. What I did was keep track of the fishes per day instead of tracking each fish individually. Yeah, that is basically what I'm doing here now. So these are the count of fishes for all the different levels, and then we're gonna loop over all of our days. And then, all right, so now I guess we need to sort of shift them. But do we have to shift them? So the number of fishes at the 0 position should be added to the number of fishes at the 8th position. I guess we can just type out this logic. So fish list 8 plus equal fish list 0. So all of the fishes that are 0 at the beginning of a day are turned into 8 fishes. So new fish that have 8 days to mature. And then fish list 0 is equal to fish list 1. So that basically decrements fish list 1 is equal to 2. Of course, this can be written in a loop for I in 0 dot dot 7. We say fish list I is equal to I plus 1. So at 7, this would be 7 is equal to 8. Which would, of course, be wrong. So we need to do 6, and then fish list 7. Actually, we need to store let old 8 equal to fish list 8. And then after all of this, we're going to say fish list 7 is equal to the old number 8 position. I guess we could have added another, like an artificial 9, and then add these to the 9, and then, or add these to the 9, but then immediately decrement them down. Let's actually do that. It's a bit of a cleaner solution. It's the same thing I talked about in our day one code here. I said we could have, instead of having this sort of if and else here, we could have done this and just added a 9 instead. Because that would, or no, set this to 7, because this would then decrement that. Right, so fish list 9 plus equals to fish list 0. Of course, the fish list zeros also need to be added to fish list 7, and not fish list 6, because we decrement them right after. Right. So that should, if we now sum these together for I in fish list, I in fish list count plus equals I, and then echo out the count. And of course, we want to test this, with our example input first. This should be pretty quick. Oh, overflow defect. Overflow? Are these numbers that big? Wait, line 7? That can't be line 7. Echo out the list of fish, or our counts. Right, these actually grow crazy big. Which of course is wrong, because this is the total that we expect for the small example, and one of these numbers is orders of magnitude bigger. So we have done something wrong here. Fish list 9 is equal to fish list 0. Let's just first just make sure that we parse this in correctly. So we have 2 fishes at day 3, so 0, 1, 2, 3. And then we have 1 at 4, and 1 at 2, and 1 at 1. So that should be correct. And then we do 1 iteration. And run this again. So after 1 iteration, of course, remove that. Right, 5 fish after 1 iteration, because that doesn't do anything. 2 iterations, all of these numbers shift down by 1. 2 iterations. Where did these 2 come from? So this one goes to here. That is correct. Oh, right. So this one copied that one. Right. I see what happened. So when I said that these, like I set this one to 7, and then we loop here and we also add that to 6. So we actually create 1 fish too many. But we know that this, right, fish list 9 is always going to be just the ones that we added this iteration. So for all the ones that we added this iteration, also add them at the end to the 7th one. There, that looks more correct. So the one that falls off here gets added, like a new fish gets created, and this fish has now a higher age, or a longer time. Well, just gestation period. I don't know how to pronounce that word in English. Right. So now this should work. Nope. Still overflowing. Let's try it with the 79. So yeah, already way too many fish. Oh right, the 9s never. Right, the 9s and the 7s never tick down, obviously. So run this through all the numbers. And set the 9s to 0 at the end of the day, because none of them should ever be 9. We just use it as an intermediary to set 8 down here. And add the 7-day fishes in. There, that looks better, but it's still not quite correct. So we expect this number to be 5,934, but it's that. Actually, so this is just a small calculator I wrote in reverse Polish notation. No, so it's not just that it's 1 iteration off. We have some other logic fault here. So yeah, this one ticks down. This one is now at 8 days. That one should be there actually. So this should be at position 6, not at position 7. There we go. That looks more correct. 5,934, which is correct after 80 days. And if we run this on the actual input, I'm also going to remove this echo right there because that's going to echo a lot of stuff. This should now be the same as our part 1, and it is. I'm going to build some confidence that this is actually a correct implementation. Let's do all 256 days. Boom. Not crashing my computer anymore, even in debug build. So it's nice and slow, full of checks. And hooray! We got another gold star. What I'm doing. Yeah, so right now I'm done for the day. I'm gonna show off, so stay around. I'm gonna show off another solution, but I'm solving Advent of code. So it's a Advent calendar made up of small coding puzzles, and you can do them like it's only like as long as you have a language that can parse text files as input and do math and output numbers, then you can use that language to solve Advent of code, which is pretty neat. So today we were calculating spawn rates of fish over time, which is actually pretty cool. And yeah, I'm implementing these in a programming language called Nim. I forget that people actually come across this stream. So Nim is a programming language. You can see sort of what it looks like here. Also, if you've been watching the stream, you obviously know what it looks like. But it's a super nice, fast little language that's not little. It's quite a complex language. It compiles via C, C++, or even JavaScript, so you can target anything. I actually have some microcontrollers on my desk right now because I'm doing some microcontroller programming. So you can program anything from like Arduinos or even smaller microcontrollers to websites. The forum here, Nimlang forum, is written 100% in Nim. The playground where you can run arbitrary Nim code is also written in Nim. So you can use the language for pretty much anything. But we're using it today to solve random small puzzles. Yeah, anyways, so as I mentioned in the beginning, or between part 1 and part 2, I really like to show off some of the other cool solutions that people come up with to these problems. And we have one here, again from, oh, Merry Christmas, David Sundararash. Wait, that might have been a raw too much. I think it's fine. Merry Christmas, David. Well, Merry Advent. It's not Christmas yet. Christmas doesn't start until 24th? Is there an official style guide, what with UFCS and the flexible casing? There is a official style guide. You can find that. It's called NEP1. Along with a lot of other stuff, apparently. Yeah. NEP1. So this is a style guideline. Basically, you want to prefer camel casing with sort of Pascal casing for, constants can do either or. Objects or types should start with uppercase, so they're sort of Pascal cased. Apart from that, it's pretty much just camel case. Of course, since it's case insensitive, you can do whatever you want. If name is easy to learn, yes and no. It's a bit like chess. It's quite easy to learn. Like syntactically, it's pretty simple. It's very familiar if you're coming from Python and if you know a little bit about types and how types work. So it's pretty easy to pick up. We have some really nice guides. I think it's one called Name for Beginners. Yeah, we have some video tutorials also. I think this one is pretty beginner friendly. So it's pretty easy to learn, but as I said, it's a really cool language that you can do a lot of stuff with, especially the powerful macro system can really give you a lot of flexibility. So some of the more complex parts of the language can be sort of hard to master, but the language itself is pretty easy to learn. So it's pretty easy to learn and to use them, but true mastery is still pretty hard. But that shouldn't dissuade you, because it's a really nice language once you get to know it. But yeah, back to the style guide thing, with the UFCS, it becomes a little bit more what you like. For example, adding to a list or to a string. Like if you're manipulating an object, you typically do, not even if you're manipulating, if your function is, or procedure or method is a word, is a verb, so something like add, or in my code, for example, something like split or strip or parse integer, which are sort of actions on their arguments, I tend to use the dot notation. Read file is sort of, I try to make it seem logical when you're saying it out loud. But for example, echo, like you could do something like count.echo. This will also work. This I haven't seen anyone do this, and there's probably a good reason for that, because it looks kind of weird, but it does work. But echo is more of a command. Like I'm not telling count to echo, I'm telling nym to echo. So that's why I put it in front. I'm telling nym to read the file. I'm not telling the string to read a file. But I am telling the string that read files return to split itself into parts. And I'm telling the parts to strip off white space and to become integers. So it's sort of, count.echo looks weird. No one would like you if you did that, because it looks weird. I'm not saying no one would like you, but no one would like that code. But yeah, there are some sort of conventions, and you normally just get used to them. Um, any usage and advantage of this language? There are definitely advantages. As I said, lately I've been doing a lot of programming on microcontrollers, and the macro system really allows you to, since it allows you to rewrite code on compile time, you can do a lot of work while your program is compiling to have a super efficient execution, because you're running your program more often than you're compiling it. And the compilation is still super fast, but you can do it like for microcontrollers, for example, where you're super limited in what you can do. It can be really nice. Like I wrote some code that reads images. It reads images on compile time and converts them into arrays of pixels to draw on screen. And that is something I haven't seen anyone do in any other language. There are probably some examples of it, but I haven't seen anyone do it. Typically, like you program microcontrollers in C++ or C, and you end up with stuff like take these images, have a make file that converts them to arrays, which I then include into my project. But with NIM, you can have a macro that does that for you automatically, which I think is pretty cool. There are a bunch of other, the type system is super great. You can have distinct types. So I have added a lot of type safety to a bunch of my projects where the underlying data type is still the same, but the logical type is different. So I could, for example, well, maybe not in this one, but if we look at part 2 from day 5, for example, here we have x and y's. We could theoretically have two different integers called like x and or x coordinate and y coordinate, and then we couldn't plus x and y coordinates together because that would probably be a bug. You can do things like if you have code that deals with physical entities like weight and force, you can make mathematic operations that automatically does the types for you, so that you end up with the right units, which is pretty cool. So, and as far as usage goes, since it compiles to C, C++, and JavaScript, you can use it for pretty much everything. And I think that is part of the reason why NIM haven't caught on as quick as some other languages, because it's not trying to solve one specific problem. So it doesn't, like when it was created, it wasn't to create the one killer app. It was rather to just improve the situation for everyone. And now we're starting to see things that I believe will be killer apps in their own fields, but sort of in, like, now we're a couple of years into NIM's development, and now we're starting to see these really cool projects that might be killer apps in their own fields, which is just because NIM is a great language to work with. So I hope that answered your question. Yeah, write it like you want to read it. Someone commented on YouTube. That is definitely the style guide that I follow. But yeah, anyways, back to this. I'm soon gonna cut this stream, but I want to show off one cool solution to day 5. So for those of you who watched me on day 5, I created this transformation with this if else block that returns a 0, a -1, or 1, and the same for the y. And just one neat little trick that I've seen people use is to use the sign operator or a procedure. So this just gives me the sign. So -1 or +1. So if this is 100, then that is +1 because the sign is positive. If it's -100, it's -1 because the sign is minus. And if they're the same, then I get 0. So this little, like this one, like inlined math function basically replaces my 4.5 line of code up here. So this could have just been that one sign operation, and I could have dropped all of this from my code. And you can end up with, like, this is 14 lines. And just this repository is actually super interesting. He has written his own AoC helper library. So you can see here he has day 5, part 1 and part 2. He has all his, like, this is common stuff. And then I'm guessing, like, I haven't looked at this, but he probably, yeah, this does different things. So he can have, yeah, just like helper stuff. And if you look at this, he has like helpers for his input and the stripped input, and it automatically downloads his input from the day that he's doing, stuff like that, which is just super cool. Again, all the neat stuff you can do in Nim. Actually, I haven't looked at his day 6. Wow, okay. Using a memoized function. That's pretty neat. Actually, recursion here. That is nice. Yeah, like that. So yeah, anyways, his solutions are also crazy fast, which is really, really cool. I'm trying to go for more, so like write it like you see it kind of deal. Like I try to do this in a sort of easy to read, easy to understand way, and try to explain what I'm doing as I'm doing it. But his crazy fast solutions are definitely cool. So yeah, that was it for today. Hope you enjoyed this stream. Hope you enjoy my recordings. All of these streams are recorded and uploaded to YouTube. So you can go back and look. If you don't catch me live, you can go back and have a look at the recordings. I think they're actually recorded to Twitch as well. Not 100% sure about that, but I think they are. So yeah, that was it. Of course, all my solutions are also available on GitHub. So if you want to just have a look at the sort of my results to all of this, you can do that. I had actually forgotten. Oops. Yeah, I'd actually forgotten to add day 5 to my repository. So day 5 and 6. So yeah, you can check out my repository. Not gonna do that on stream. You can check out my repository and see all my solutions. Again, hope you enjoyed this, and hope you will join me for another stream. I hope to keep these going at least for quite a while. So thanks again, and have a good